2a. This is another log equation. Okay? We have log 6x equals log x plus 6, log x plus log x minus 1. The x is inside the logarithm. Actually, I feel like doing 2b first. So we're going to start with 2b. It also is a logarithmic equation because there's an x inside the logarithm. 2b is a little bit easier than 2a. There's less logs. And 2a has a shortcut that I'm going to show you. So that's why I want to leave it for the end. But 2b, again, our main goal when solving logarithmic equations is to get it as a single logarithm. So I have two logs. Could I put those together to become a single logarithm? Yes. It's a log plus a log. Again, don't distribute that log base 2. It's not a number. And so now I've got it as a single logarithm. And for whatever reason, this next step is the step that everybody forgets. Why did we get it as a single logarithm? So we could use our definition and change it to exponential form. So it's a single logarithm. What's the base? The base is 2. What's the exponent? The exponent is 3. What's the answer? If I distribute and multiply the x plus 2 times x, I get x squared plus 2x. Once you've changed it to exponential form, your x will be in a way that you've solved before. This is a quadratic equation. How do you solve quadratic equations? You make one side equal to 0. We factor. This one factors nice. And solve. And then in addition, once you've solved logarithmic equations, you always have to check for extraneous roots. So in this one, we want to check if I plug in -4, will I take the log of a negative number? Yes. And it only has to happen once. But in this case, it happens in both of them, right? You plug in -4 into the first log or into the second log, you're going to have log of a negative number. That makes it extraneous. So you need to cancel it out. Okay? If I plug in 2, 2 works. So 2 is good. It does happen. In fact, it's a good question. What happens if you both answers turn out to be a problem when you plug it in? It just means that this question has no solution. And another thing that I think that it's important is the way that you asked that question. You said, what happens if both answers turn out to be negative? It's not a problem if our answers are negative. I can make a question where both answers are negative and they both work. I can make a question where both answers are positive and they both don't work. It's not your answers that are the problem, but it's what happens when you plug those answers in. So for example, let's say your original equation had log 1 minus x. Can you see if you plugged in -4, you would get log of 5. It would be okay. But plugging in 2 would give you log of -1, then the 2 would be bad. So that's another thing. You can't just cancel out an answer because it's negative. You have to plug it back into the original equation. Now, about 5 years ago, the final exam did exactly that. I thought it was a little bit mean. The very first question of the exam, right? You're going into a 3-hour exam. It's worth 30% of your mark. You're a little bit nervous. You get to the first equation. It's a log equation. You solved it, and your answer doesn't work. So your very first question, you have to write no solution. Your confidence is shattered. And you turn, it's like, oh. And that happened. The very first question of the exam had no solution. It was a log equation with an extraneous. It's just not nice. Most good exams now, they say you should start off with a couple of straightforward questions that if you've studied, you should know how to do them. There are no surprises. The hard ones should come in the middle when you've built some confidence. But no, there's right off the bat a really hard question right to start. So it wasn't very nice. I'm sure I'm sure a couple got scared by that. Wow, that's not what I wanted to have happen. Oh, it almost worked. Perfect. Just the bracket didn't show. Okay, here is A. It's a log equation. I'm going to do it the standard way first, and then I'm going to show you a step where we could have done a shortcut. So in the standard way, you want to write things as a single logarithm. So I've got log 6x on this side. Here I have a log plus a log. So if I want to put those together, I can do that by multiplying. It'll be log x plus 6 bracket times x minus 1. Now, I still don't have a single logarithm. I have a log on one side and a log on the other. And the only way I can combine logarithms, simplify it from the right-hand side of those formulas to the left-hand side, is if I'm adding or subtracting. But in order to do that, I would need to have them on the same side of the equation. So I'm going to move, so I have x plus 6, x plus 1. I'm going to move this log 6x to the other side of the equation, which would make it subtracting. I still don't have a single log, but now I have a log minus a log. Can I simplify that?
You can make it use a log law.
You can use a log law to say when you subtract, you divide inside of your logarithm. I guess I don't need brackets on the bottom. Just have 6x. And now we have a single logarithm. Oh, why did it change to plus 1? Just because of that skill that sometimes you do where you change things without realizing it? Yes. See how the minus sign changed to a minus sign with a little blip? I don't know why it got that little blip.
You made a mistake.
I made a mistake, obviously. And it slowly changed it to a minus sign. Yes, it should stay a minus sign. So now we have a single logarithm. What can we do with a single logarithm? Why do we get a single logarithm? To use the definition to change to exponential form. What's the base? Can you see you forget that step, eh? The base is 10. The reason you forget that step is because it's such a weird algebraic step to go from this to say, I'm going to use my definition, the base is 10, my exponent is 0, equals x plus 6, x minus 1 over 6x. What is 10 to the 0? 1. So if I multiply both sides by 6x to get rid of the fraction, 6x times 1 will be 6x, and on this side those 6x's would simplify. What kind of equation is this? It's going to be a quadratic, so you would have to move everything over to one side. I'm going to multiply this out, so x squared plus 5x minus 6. I'm going to subtract the 6x. Can we factor that? X minus 3, x plus 2. X is equal to 3, and x is equal to minus 2. Back to our original equation. We have to check our answers. If I plug in 3, it's okay here. It's okay in the second one. It's okay in the third one. 3 is okay. If I plug in negative 2, it's bad in the very first one. I don't even have to check the other ones. I know this one is extraneous. So in these three examples, they're a little bit misleading because none of them gave you negative answers that worked, but negative answers sometimes can work. Just because our answer is negative, that doesn't mean it doesn't work. You have to plug it into the original equation. Would you like to see one where a negative answer works?
Yes, please.
All right, I will make one up. Oh yeah, I was going to show you the shortcut for this one before we do that. Okay. View. Entire page. Okay, I made it a little bit smaller here. The shortcut can actually occur after step 1. And this shortcut only happens when you have a single log on one side and a single log on the other side. Okay? It's sort of connected to what we do in our exponential equations. When you take the log of both sides, you could put a single log on one side and a single log on the other side. And you can do that because both sides were equal to start with. So if I have log of 6x is equal to log of this, by logic, what does that mean about the red boxes? They're equal. So I could have said at this point, 6x is equal to x plus 6 times x plus 1. Can you see the logic there? How many steps did I skip? Quite a few. Okay?
Negative 1 again.
Oh, what did I, that's crazy.
Make sure to highlight this section.
Yeah.
So we go back to the-
There we go. -1 again. Okay.
Wow, that actually saves you so many steps.
That saved a lot of steps. Plus, it saved the step where you always forget the changing to exponential form. Other things that happen in this that end up being bad for students, for whatever reason, in the middle of a question you get 10 to the 0 and you forget that that's 1.
I actually thought that 1 is equal to that to the rest of the equation.
So that's the shortcut that you can use in these ones if you get a log equal to a log, because it's based on logic, and that's fine. Okay, you wanted one question, so we'll make this C. I'm going to have this one log 3 of 1 minus x equals 3 minus log of x plus 11. Oh, I like this question. So with this question, one of the reasons that I like this question that the other ones didn't have is it's solving for a log equation, which our other ones did. X is inside a log. So your main goal should be to write it as a single logarithm. Do we have a single logarithm? No. We have a log on one side and a log on the other. Why can't we use the shortcut in this case? Because it's not a log equals a log. There's an extra 3 in there. So we still have to use our log laws and put them together. The only way you can put logs together is if they're on the same side of an equation. So the very first thing I'm going to do here is add log x plus 11 to both sides. That puts my logs on the same side. And now if I multiply, whoops, I forgot the little 3 here. Need to have the same base. Now, I'm adding 2 logs with the same base. That's important because if that 3 wasn't there, you can't combine those logs. You can only combine logs if their bases are the same. And so now I can use my log law that says when you add, you multiply. And so we've succeeded in getting this to a single logarithm. What's the base? All right, this is a step you're going to forget. Once you get a single logarithm, change to exponential form. What's the base? 3. What's the exponent? 3. Okay? That's your answer. What kind of equation is this? Quadratic. So we're going to have to make one side equal to 0. That's 27. If I multiply this out, I'm going to get x plus 11 minus x squared minus 11x. I'm going to make this side 0 because I like my x squareds to be positive when I'm solving. This would be minus 10x. I'm going to move it over, be plus 10x plus 16. Does it factor nice? X plus 8 plus 2. So x is equal to negative 8 and x is equal to negative 2. Zoom it so we can see the entire page. Let's plug negative 8 back into our original equation. Your gut feeling so far has been every negative number doesn't work. What happens when I plug in negative 8 into here? 1 minus negative 8 is 9. That's okay. What about on this one? Negative 8 plus 11? Positive 3. It works. What about negative 2? 1 minus negative 2 is 3. That's okay. Negative 2 plus 11, that's 9. That's okay. They both work. No extraneous roots on this one whatsoever. Okay.
Mr. Ron, they should have made an exam where all the answers were not possible.
Every single question, there's no solution?
Just to see how bad people do.
Okay, for the rest of class, we are going to work on these log equations, 11 and 13.